Part A. Show that root x plus root y all squared equals x plus y plus 2 root xy. We can rewrite root x plus root y all squared as root x plus root y times root x plus root y, which we can then FOIL out as follows. And then we use the fact that root a times root b equals root ab, which follows from this working, to rewrite the expression as x plus root xy plus root xy plus y, which simplifies to x plus y plus 2 root xy on bringing together like terms, as required. Part B. Hence write root 7 plus 2 root 10 as the sum of surds. Since this is a hence question, we have to use part A to show the result. And we note that the left-hand side is the square of a sum of surds, and we also note the similarity between the quantity under the root sign and the right-hand side of the expression that we are working with. And so it is natural to write 7 plus 2 root 10 equals x plus y plus 2 root xy, and to try and extract the values of x and y from that equation. And we see that we must equate 7 and x plus y and 10 and xy to give the following simultaneous equations, which we can solve to give x equals 2 and y equals 5, either by inspection, since the numbers are rather small, or by solving formally as follows. And so from x plus y equals 7, we have y equals 7 minus x, which we substitute into xy to give us x times 7 minus x equals 10, which finally simplifies to the following quadratic equation. That equation factorizes into x minus 2 times x minus 5 equals 0, which solves to give us x equals 2, y equals 5, or x equals 5, y equals 2. And we substitute those values back into our original expression to give root 2 plus root 5 all squared equals 7 plus 2 root 10. And 7 plus 2 root 10 is the quantity which we are trying to form. And so finally, on taking the positive square root of both sides, we have root of 7 plus 2 root 10 equals root 2 plus root 5, which is a sum of surds as required. Part C. Show that root of 11 over 5 plus 2 times root of 2 over 5 equals root 5 plus 5 root 2 all over 5. And here we note that the right-hand side is again a sum of surds, so we use the same method as we did for Part B, where we had to rewrite a similar expression under a square root as a sum of surds. But here, in fact, it makes sense to simplify the right-hand side first, which we do by first splitting the top-heavy fraction into 2, and then by rewriting the first surd expression using this relationship, 1 over root a equals root a over a, as 1 over root 5. And now we take the expression from part A and take the positive square root of both sides to write the left-hand side as a sum of surds and the right-hand side as an expression under a square root sign. And now we note that the expression root x plus root y can be turned into 1 over root 5 plus root 2 if we set x equals 1/5 and y equals 2, which gives xy equals 2 over 5. And now by substitution we see that root 5 plus 5 root 2 all over 5, which equals 1 over root 5 plus root 2, equals, by substitution into the right-hand side of the expression above, the square root of 1/5 plus 2 times the square root of 2 over 5, which of course is root 2 1/5 plus 2 times root 2 over 5, which finally simplifies to root 11 over 5 plus 2 root 2 over 5. And so we have shown that root 5 plus 5 root 2 all over 5 equals root 11 over 5 plus 2 root 2 over 5 as required. Part D. Hence show that 11 over 10 plus root 2 over 5 all to the power minus 1/2 is greater than 3/4. And since this is a hence question, we must use the result in part C. And that raises the question, what exactly is the relationship between the quantity in part C and the quantity in this question? Now, the quantity in part C involves a square root. The quantity in this question involves a negative 1/2 power. In addition, the numeric parts of these quantities are similar but slightly different, and we will have to rewrite one in terms of the other. And first we note that u to the power half equals the square root of u, and u to the power minus 1/2 equals the square root of 1 over u. And secondly, we rewrite the quantity in this question in terms of the quantity in part C as follows, by noting that they seem to differ by a factor of 2. So 11 over 10 becomes 11 over 2 times 5, and root 2 over 5 becomes 2 over 2, which is 1 times root 2 over 5. And from that we factor out 1/2 to leave behind in the brackets the quantity in part C. And before continuing, we recall that in fact the quantity that we have just derived appears under a square root sign in part C, and furthermore that it is equal to the sum of two surds. And now we start working towards the inequality that we wish to derive. So we consider 11 over 10 plus root 2 over 5 all to the power plus 1/2, which we rewrite as follows using the relationship we've just shown in part 2 above. We distribute the half power over the product as follows, and we can rewrite that as 1 over root 2, which is 1/2 to the power 1/2, times 1 over root 5 plus root 2, using the relationship in the blue box, and bearing in mind that a half power corresponds to a square root. And multiplying out the brackets, we get 1 over root 2 root 5 plus 1, which simplifies to 1 over root 10 plus 1. Now at this point, we ought to start wondering where our inequality is going to come from. Well, we have a fairly simple numeric expression, and from this it's quite easy to derive an inequality. And we are going to concentrate on the root 10 part of this expression. Now, first note that 10 lies between 9 and 16. 9 and 16 are square numbers. And that means that on taking square roots, that root 10 lies between 3 and 4. And that supplies us with two inequalities for root 10. And now we use this inequality for root 10 to construct an appropriate inequality for 1 over root 10 plus 1 by using the rules of inequalities for real numbers. So 3 is less than root 10 tells us that 1 over root 10 is less than 1 over 3, because for real numbers a and b, if a is less than b, then 1 over b is less than 1 over a. And we add 1 to both sides to find that 1 over root 10 plus 1 is less than 1 over 3 plus 1. And so 1 over root 10 plus 1 is less than 4 over 3. And so we have that 11 over 10 plus root 2 over 5 to the power plus 1/2, which equals 1 over root 10 plus 1, is less than 4 over 3. And so now the quantity that we are interested in, 11 over 10 plus root 2 over 5 to the minus 1 half, which equals 1 over 11 over 10 plus root 2 over 5 to the power plus 1 half, is greater than 1 over 4 over 3 by using this relationship once again. And so we finally have that 11 over 10 plus root 2 over 5 all to the power minus 1 half is greater than 3 over 4, as required.